Hi, my name is Kyle Faller, and I'm the co-founder and CEO at Intelline. We are a young company developing a new diesel generator architecture from the ground up, specifically for heavy industry and mining needs. Exciting developments in alternative energy technologies show promise for more sustainable energy supply in mining, but no one solution fits all needs. Industrial diesel generators continue to be depended upon, but the pressure to reduce emissions and operational overhead is ever increasing. This creates an opportunity for a new combustion engine architecture to replace archaic designs. Today, I will be speaking about our generator technology, how it can help displace diesel fuel use today and transition away from diesel in the future. I will briefly cover existing combustion generator technologies, introduce our modular linear generator technology, walk through an example case to show the fuel savings, and then conclude with some final notes on fuel use in the future. Now, there are two main forms of generators: piston generators and turbines. Piston generators are relatively simple in principle and can effectively serve a wide range of power needs, from a few kilowatts up to multiple megawatts. The broad application of piston engines and generators has evolved designs to be easy to understand and maintained by the average technician. Despite the many moving parts in piston engines, their commonality makes parts and technical knowledge abundant. Now, piston generators are only about 30 to 35% efficient and have limited ability to match demand without substantial decrease in efficiency. Now, despite having one main moving part, turbine generators are substantially more complex in design and require specialized training to properly maintain. The higher tolerances, specialized materials, and unique parts in turbine engines make maintenance more difficult. The turbine engines are efficient and compact power solutions, especially for power demands in many tens of megawatts. In combined cycle power plants, turbine generators can achieve excellent efficiencies of over 60%, but in standalone use, efficiencies are still only 30 to 40%. Load matching is also still quite limited. Now at Intelline, we are developing the Modular Linear Generator, or MLG. This generator architecture retains the simplicity and ease of service of piston engines, but eliminates many of the unnecessary moving parts that cause wear and efficiency loss. The MLG can achieve thermal efficiency of over 50% and has highly adaptable hardware to enable excellent load matching. The basic layout of the MLG involves a cylinder block in the center of the unit and two linear electric generators at each end. This engine does not rotate. The combustion in the center of the unit pushes the pistons apart, which bounce off of gas springs at each end of the unit. The mover shafts and pistons move back and forth in the unit, and the relative motion between mover and stator is how electricity is made. The Intelline MLG is the only four-stroke opposed piston engine architecture. There are no changes to the fundamental science, keeping the engine simple. Instead, we combine the best of proven strategies that eliminate friction and thermal loss into one compact architecture, allowing the MLG to achieve up to 40% lower fuel consumption. Finally, the modular design approach makes specification and versatility convenient. Modules are produced in 50 kilowatt increments and can be stacked together to achieve higher power outputs, up to 3 megawatts of power in a single enclosure. This makes part availability convenient as modules are consistent across many generator specifications. Modules intelligently react to demand and can deactivate entirely, allowing high efficiency to be maintained across full load to near idle conditions. And now on to the exciting bit. We have created an example loading case to compare a modern 2 megawatt diesel generator and highlight the dramatic difference in fuel consumption between the MLG and traditional technology. Now, fuel price varies quite a bit depending on location, but 40 cents per liter was used for this example. Here we have an example 24-hour load curve for a 2 megawatt generator. We can see that in the early mornings, there's only a small amount of power usage, perhaps as the site is inactive, but only some demands remain present, such as lights. We can see demand change as more equipment comes online and spikes and drops throughout the day as large equipment is turned on and off. Now here's why real-world use matters so much for the efficiency consideration. A traditional diesel generator has a peak efficiency at full load, but at lower loads, the efficiency drops off substantially because the engine geometry is mostly fixed. The Intelline MLG, by contrast, has variable displacement, compression, and valve lift and timing. This means that the engine properties can be altered to maintain near full load efficiency across varying power demand. Now this graph shows the obvious reduction in fuel consumption as a result of higher thermal efficiency and more effective load matching. And similarly, this plot shows the consequent reduction in CO2 emissions. Now I move through these plots quickly as the final figures are much more meaningful. In 24 hours, the traditional generator uses just over 6,600 liters of diesel fuel. And for the same demand, the MLG uses just under 4,600. This is a daily cost difference of $830, and over the course of a year, the fuel savings would total a whopping $303,000. In addition to the financial savings of burning less fuel, the MLG would also produce 2,030 tons less CO2 than the traditional generator per year, and the greater degree of control over the combustion process also substantially reduces the nasty NOx and soot emissions. The adaptive nature of the MLG hardware makes it easy to tune for a variety of common and emerging fuel types. The cylinder arrangement allows convenient access for multi-fuel systems, such as combination diesel natural gas, diesel hydrogen, diesel gas, and more, as well as future retrofits. We designed the hardware to make it easy for customers to start with traditional fuels and smoothly transition to better fuel types in the future. For example, biofuels and synthetic fuels involve carbon and greenhouse gas capture to create, and using such fuel types brings the overall energy solution closer to carbon neutral. At Intelline, our motivation is to implement practical, economical generator solutions today that are designed to support a zero-carbon future. If you have any questions, please do not hesitate to reach out. Thank you.